Before I begin, little bit disclaimer. All the views expressed during this talk, presentation, all opinions, content has nothing to do with my employer or anybody. They solely belong to me. Little bit about me. Thanks for the short introduction. I'm a senior security technical program manager, and I mainly manage the cryptography and application security program at world's most disruptive tech company. Sorry, I'm not allowed to take the name. You guys can figure it out later. My passions are software security, practical cryptography, and application security lifecycle management. First 10 years of my life, I spent doing a lot of technical security evaluation, and then realized that security is never about technical controls. It's mainly about people and processes as well. So that's what I do now. Lately, I got certified as a yoga instructor as well, and I teach meditation at a small studio in Northwest Austin. So that's about me. In today's talk, I'm going to talk about why we should evaluate libraries, how libraries are actually different from application, then a little bit about how we generally evaluate applications, and how that application review process is not applicable to library. Then I'm going to cover at high level how we should evaluate libraries. And I have chosen today our very favorite OpenSSL as an example. So let's begin. How many of you are developers? Awesome. Because this talk is mainly for developers, there is nothing new that a security professional doesn't know here. It's mainly for developers. Time has come for developers to take security in their hand, take complete ownership. Of course, do consult your InfoSec department whenever necessary, but don't let InfoSec department become hindrance in innovation, because you guys like to run at a certain speed. How many of here on the attack side? Those who are security professionals. How many of you are on the defense side? How many of you do everything? Awesome. So, you know, what I've seen in my last 10 years of career is there is so much focus on application, pen test. We scan shit out of application. But what we really don't, for every single release, we have to run it through scanner, right? That gives us so much false sense of security. Do we really think that's security? Just scanning your application bunch of times, getting it pen tested by your own red team or external. Yeah, they do find creative flaws in our application, but is that really security? I know there is no such thing as 100% security, just the way there is no such thing as a totally bug-free software. But do you guys do something extra that nobody else does? According to a study done by Contrast Security, 80% of the application code contains library. And time has come, we need to start taking a look at our libraries carefully and closely. Because one vulnerability in a library can replicate on all the products and services which are built on top of the libraries. Make sense? So I went to internet. There is this cool website, trends.builtwith.com, and I put OpenSSL and pulled data for top 1 million site. In top 1 million site, you can see almost 55,000 sites are using OpenSSL. So OpenSSL is that widely used security library. It's a security library. So what is the assumption here? It has to be secure. And it's been around mid-1990s. Just take a look at this slide. This is the vulnerability trend for OpenSSL. As time is passing, security researchers are finding more and more security issues in a security library. This slide shows security vulnerabilities by different attacks. So DOS, the second column is for DOS attack, third one is code execution, then buffer overflows. Security library, and we are here, 2017. Till date, security researchers have found 181 security bugs in OpenSSL, and we use OpenSSL blindly, right? How many of you use OpenSSL in one or more products? So before you started using OpenSSL, did you take a look at how many known vulnerabilities it has? No. You know, our development teams are in rush to bring the product to the market, right? They don't have time to do this analysis. That's why it is important for developers to take full ownership of this type of activity. This is another slide of vulnerabilities identified per category. So before we talk about how we should review libraries, I want to quickly go through some steps that we perform as application security review process. Now, irrespective of the software development lifecycle model, this is what we do. We do design architecture, where we break down the product, look at all the components, full end-to-end, full stack. Then we do threat modeling. We come up with all sort of threat scenarios where the application can be compromised. Then we do static code analysis, followed by manual code analysis if you guys have time. If you guys don't have time, then we just rely on those static code analysis tools, and we all know the high false positive rate, the high true positive rate. I haven't come across a single static code analysis tool till date which is really efficient finding bugs. How many of us really spend time configuring the static code analysis tool?
Don't get us started on that.
So if it is so difficult to configure for security professional, imagine how difficult it is for developers to figure that out when they have tight deadlines, right? Then of course we do dynamic app testing. Again, same issues, high false positive rate, low true positive rate. And at the end, we want endorsement from the external third party. So we go get pen testers. I'm not saying pen testing is bad. Pen testing is awesome, but it's expensive. It takes time. We can afford maybe once a year. And pen testers may not necessarily have the internal knowledge that developers have. So guess who is in the most empowering position here? Developers. There is no security team in the world who has time, resources to spend as much time as developers can spend on security. So if we could empower our developers with the right tools, technology, methodology, they can do their level best. This is same thing, but for a secure DevOps pipeline. Now, whatever manual stuff we were doing in waterfall SDLC or Agile, we try to replace it by automation as much as possible, and that's how we scale. So for every single build, we do the same thing, static code scan, then some automated configuration check, dynamic scan every once in a while, and whatnot. Next one, as the organization becomes more and more mature and they do all these steps, they start looking into full stack security. Can you guys read the slide, or it's too small?
It's too small.
I'm sorry. I don't know how to increase the text, but I'm gonna read it quickly for you. So first, we do security assessments at app level, threat modeling, architecture review. Then we do security assessments at code level. That's basically our automated code scan, static code scan, or maybe manual code review. Then, if the organization is mature enough or the security department is mature enough, they start looking into the open source libraries, components, and framework the product team is using. And in that also, they basically try to find out what are the already known vulnerabilities are there, or what are the operational dependencies are there. Is there any licensing risk? Then at the web application front-end stack level, we do dynamic app scan, maybe conduct internal pen test and then external pen test. At container level, we do hardening checks. Maybe if you're very proactive, you run that CIS benchmark agent every time you start your Docker container. Then at host VM level, same stuff. We look for hardening checks, we look for missing patches, we do vulnerability assessment, internal and external, same with the network stack. If your product is using crypto, then we do crypto specific testing, HSM specific testing. So those who are kind of mature organization and doing this for a long time, they do all this full stack security evaluation for their mission critical application. Not necessarily for all the products, because this is a lot of work. This is more work than getting the product out, right? So it's really not that practical. So now, today's talk focuses on libraries. So let's focus on the third layer, open source libraries, components, and framework. Besides looking at open source vulnerability, operational dependencies, and licensing risk, what is missing? Anybody? What else we can do?
Another manual code review for that.
Yes. Anybody? What else? You're right on spot.
We didn't hear.
The question?
No, his response. The response. We didn't hear.
Oh, he said manual code review. If we do a manual code review for our libraries, that will be really awesome. So let's see. Yes, static analysis as well, manual code review. So what we need to do besides finding known vulnerability, dependency issues, and licensing risk is find out what are those unknown vulnerabilities which might have been created in the custom code that our developers have written on top of libraries. CVE database will tell you what are the known vulnerabilities, but we don't know what are the vulnerabilities in the custom code which is on top of the library. And of course, misconfiguration. Developers are under tight deadlines. Security is not priority for product owners or executives. Nobody has time to write secure coding guidelines or how to use libraries securely. So misconfiguration is another very vulnerable area where developers tend to do mistakes, because everybody is in rush. Now, the application review process that I just described a couple of slides back, why it is not applicable to library. If you take any proper foundational dev framework or any programming language framework, in that framework, it consists of several components. Each component can be treated as individual library or they can use together, right? And if we start doing the full stack security evaluation for these huge, complex foundational dev framework, it will take us years. That's why we need something lightweight, fast track. Another good reason why we should have separate review process for libraries is the data flow in library depends on the host application. The data flow diagram for a host application is kind of different. The attack surface for an application is somewhat different from attack surface of a library. And last, the threat agents are different. Now let me consider example. Again, let's think about OpenSSL in application space. Say it's an Android phone which uses OpenSSL. OpenSSL in application space and OpenSSL in kernel space. Attack surface is different, right? When OpenSSL is used by application, I'm more worried about application level threats. Web application, SQL injection, cross-site scripting, maybe privilege escalation and whatnot. When OpenSSL is used in kernel, my threats are different. I want to see how I can take complete control over the root. Make sense? So that's why we can't use the same method that we use for applications in library evaluation. Another good example is threat agent. Libraries are a bunch of functionalities defined in the form of APIs. Application is a lot more than that. Application has several external interfaces. Libraries have very well defined interfaces in terms of API. Now, when I look at threat agent for libraries, it's truly the developers, the naive developers, or even the admins who don't know how to use library. In case of application, the threat agents are the malicious users. Does it make sense how libraries are different from applications? Good. But the good news is we can use the same state-of-art framework to evaluate libraries, but tweak it slightly differently. We don't have to do extensive steps. In the next slide, I'm going to tell you what we should consider as input to the library. So, security folks or developers who have security focus, they can go through all the product documentation, wiki pages, design documentation, source code, API documentation, whatever documentation is available on the library, just go through that and then create list of 4 things. One is implicit security controls. Second, explicit security controls. Third, entry and exit points. And fourth one, find out what's the custom code written on top of the library. These are the 4 things we need to know. Now you will ask me, what is the difference between implicit security controls and explicit security controls? Explicit security control is something that is offered by the library by default. For example, if there is input validation filter, every single input that is passed to the library APIs goes through input validation filter so that it can avoid all the injection flaws. That is something offered by default. So that becomes explicit security control. Now what is implicit security control is, it means something that is offered by choice. For example, say that again? Yeah. I'm thinking about a crypto library. I have one more example coming up, but something where it's the responsibility of the developers to pick one of the mode. TLS. So it's developers' responsibility to configure the library with the right TLS configuration. He could pick TLS 1.0, or he could pick TLS 1.1 or 1.2. In that case, if we don't educate our developers what is the secure choice, then we introduce risk by design. Next one is custom code. Again, although we use all sort of good tools to find known vulnerabilities, there is always a risk on custom code. Unless we evaluate the custom code, get it peer reviewed or whatever, we can't find what are the known risks are there in the custom code. And last one, entry and the endpoints. Now my developers always ask me, Trupti, tell me what is a security control? What is a security functionality? I don't understand your security language. Then, we security people, we use this security language all the time. Even though my developers are working on security products for years, they use some other language. So they don't understand what is security to you may not be security to them. So when they ask me, Trupti, tell me what are security controls in the library, I said, all the APIs which implement confidentiality, that means data at rest, encryption for data at rest, or encryption for data in transit, availability, integrity, any crypto stuff falls under security functionality. Anything to do with identification, authentication, authorization, even the function level access control check falls into security controls. Accountability, auditing, non-repudiation, any privacy stuff, where you replace the sensitive data with bunch of random data. Any of the stuff, any of the 10 principles which are discussed here, if your APIs are implementing those or supporting those are your security control inside the library. And you need to make sure that as a naive developer, you don't bypass those security controls by doing wrong choices. So we request our developers to list these implicit security controls, explicit security controls, and again, the code modifications that you have done to third party. Does anybody have any question here? Pretty clear. The next, fine, I have a list of implicit security control, explicit security control, entry, exit points. The next step obviously is threat modeling. In a typical threat modeling scenario, when it comes to application, we try to come up with scenarios in which, as an attacker, how I can hack into this application. But when it comes to library, it's really not about hacking. Library is deep down here. When it comes to library, you need to think how our developer can misuse the library. And as a result of threat modeling activity, you need to list how the library, what are those misuse scenarios, and then what are the correct controls to avoid those misuse scenarios. And this could be just an hour-long activity. Once you have the list of implicit and explicit security control, this becomes really easy. Next one is code change. As this gentleman and Josh mentioned, there is absolutely no change when it comes to code analysis. You can use your static code analysis tool and manual code review sessions to do code review. The goal of this activity is really to find implementation bugs. Security testing, again, when it comes to security testing, you can use Burp or any of your dynamic security testing tools, hook basically application with the library and see, do the exact same things. But what I tell my developers is, as soon as the security testing is over, you have all the results in the security plan, give it to your developer and ask them to write automated test scripts. So that every single time they add more stuff, all they have to do is write new security test cases for the delta. And this really helps to speed up. If you have very well covered automated test case scenarios, you don't even have to run scanner every now and then. This improves speed so much. And this is so accurate that there are no false positives, because this is something customized, written by your own developer who knows inside, outside of the library. Last one. So once we finish all this, what are we actually looking for? Again, when we analyze and check the security of the explicit security controls, we see what is secure by default. We kind of harden the library's configuration. Then, maybe a team of 1 or 2 developers. It's really hard to read. Well, never mind. Sorry. Maybe 1 or 2 developers worked on that library, but a team of say 15 developers or 100 different teams are going to use that library. So for them, create a simple wiki page which will list how to securely use this library. All the implementation bugs that you find during static code or manual code review and security testing, you can log them as risk and ask your developers to fix it. And last but the most important thing, how you're going to scale the usage of secure library. In AWS, we have something called cloud formation templates, where developer clicks one button and the whole stack is spun up. So what we do, we basically help them with secure hardened code. Throughout the stack, everything is hardened, especially around libraries. We don't want our developers to spend time thinking what is secure, what is not secure. And this is exactly how we scale. Now let's take example of OpenSSL. If somebody has to review OpenSSL, how can they go about it? So first of all, OpenSSL has a wonderful security guide which lists all the security functionalities, crypto cipher suites OpenSSL uses. Second, do take a look at API documentation for more granular specific information. Third, OpenSSL has been validated using FIPS 140-2 standard. How many of you are familiar with FIPS? So FIPS 140-2 is really not a security standard. It's a crypto standard. It only looks at cryptographic implementations of those cipher. It doesn't look for memory, corruptions, or buffer overflow. So I would not say this is a gap in FIPS, but this is kind of shortcoming. We security professional, we have tendency to look at security standard as if they are like, holistic, full end-to-end, but that's not the case. So because OpenSSL has crypto functionality, it becomes important to use a FIPS validated module. And last one, source code. Take a look. If you're going to use OpenSSL widely, probably it is important to invest good time looking at the code and find out those granular configurations that your developer needs to know in order to use OpenSSL securely. What will be the output of this activity? Again, as I said, implicit security control. In this case, what are the ciphers, key sizes, modes are offered by OpenSSL by default? For example, lately OpenSSL does not offer single DES. It's broken, so it doesn't allow. Few years back, it used to allow, and it was up to the developer to select it. Second one, what are the explicit security control? OpenSSL has something called self-test. Any one of you familiar? So self-test is something like how, as a consumer, how will I make sure that this cryptographic implementation is not corrupted? So there will be an integrity test running every time OpenSSL instance starts. Or there will be known answers test for encryption and decryption, just to make sure the algorithm is intact, the implementation of the algorithm is intact. Now, the reason I have put these in explicit security control because this is something developer don't need to configure. It is already available there. In case of implicit security control, that's cipher key sizes you need to pick. For example, if you use triple DES in a 2-key mode, that gives 112 bits of security, and it's not sufficient. If you use triple DES in 3-key mode, that gives 168 bits of security, and that's what you really you should be using. But how many developers really know? How many security professionals really know this? So this is a very granular information that you need to look for and provide right guidance to your developers. I know it's hard, but if you're going to use OpenSSL in your products and website, why not spend time? Third one, as output, we need to look for known vulnerabilities. We need to look for unknown vulnerabilities and create that security guidance. And depending on your consumers, if you have mass number of developers who are going to use your implementation, then you might want to create a secure by default implementation where it is kind of hardened for all the configurations that you have looked. Now, because I have picked OpenSSL, I felt like adding this slide. OpenSSL has so much crypto, and it is outside the skill set of any pen tester or even AppSec professional, unfortunately, because crypto is hard. So for cryptographic libraries, we have to go through formal verification. And again, I'm not asking you to go through FIPS validation because it takes time, it's expensive, and it's pain in neck. But what you can do is take their standard, take a look at what is applicable to, I'll be sharing these slides later, so don't strain your eyes. What is applicable to your software libraries? I'm going to pick one thing. Cryptographic key management. How the keys are generated. Is my seed is equal to seed key? Is the entropy supplied to the random number generator, which is ultimately responsible for key generation, sufficient? All those good stuff FIPS offers. So go download FIPS standard. The specification is available to everybody, and take a look at those crypto functionalities. Sometimes things are beyond pen test, and this is the area. Now, why just doing FIPS 140-2 validation, or why just looking at crypto implementation is not sufficient. Because in FIPS certification, they only look at the implementation. They don't look at the end-to-end security of the library. And one of the example is, okay, how the keys are generated, entropy, fine, how the key is zeroized within library. Once you see the red boundary, this is the logical boundary. Once the key leaves the boundary of the library, it is the responsibility of the application to handle it securely. And FIPS 140-2 or any cryptographer don't give a damn. This comes under application security. So we need to make sure it is covered end to end. And that's the reason OpenSSL has so many vulnerabilities. In spite of being reviewed so many times. I used to be a FIPS validator. I used to review OpenSSL and 6 months, boom, there is a vulnerability. Looking at buffer overflow was not part of my job as a validator. Now as a holistic security professional, I look at everything, crypto as well as AppSec. So yes, going back to libraries, as a developer or security engineer helping our developers, we need to look at everything that library implements. This is one nice quote by Ross Anderson. I absolutely love it. I'm going to read it. Unfortunately, the computer security and cryptology communities have drifted apart over the last 25 years. Security people don't always understand the available crypto tools, and crypto people don't always understand the real world security problems. Make sense? We need to work together. So yeah, this is conclusion. We need to focus on libraries and not just application, because 80% of the application code is actually library. Then we must evaluate libraries, because one vulnerability in library gets replicated on all the application services product which are built on top of it. So if your organization is using, these are the 4 libraries or dev framework, probably it's really good idea to spend time hardening it by listing the explicit security control, implicit security control, and doing implementation specific security checks. In case of libraries, data classification and flow is irrelevant, because the data flow of the library really depends on the host application. If we have like thousands of applications, we tend to classify those applications. Oh, I'm just going to look at the red application or the mission critical applications. I'm going to look at these financially critical applications. But in case of library, there is no such classification, because a library can be used by any application. So all libraries must be evaluated. A single bug in a security-focused library could turn a big problem. So every bug in a library is a security bug. And if you want to really scale, help your developers, then create secure by default implementation of libraries. Thank you guys. I'll take questions.
Are there any questions?
Have you found any good ways to inventory these open source libraries to start off with? Like, I mean, I know there are like commercial versions and stuff, but anything, like how do you first inventory them even before like knowing what vulnerabilities are there?
Sure. Can you hear me? I'm pretty loud. So I like to work backward. Things differ from organization to organization. May I know how many applications or product your organization has?
We are over 2,000 people, so we have a big shop. So that's one of the problems.
So what? Yes. So what I did, I created a simple survey, sent it to all business unit, and I asked them to state the programming languages they widely use for developing their products and application, and of course the development framework and libraries. So I kind of worked backward, and it really worked. then I had this finite list of libraries that I needed to worry. Did I answer your question?
Yeah. We were looking at some like tools out there to see that solves the problem, but I see what you're saying. Like,
See, the thing is, you can purchase Black Duck,
that's what
or
we don't know.
but the thing is, Black Duck is going to help you identify known vulnerabilities. It's going to help you identify dependency risk, and it's going to help you with licensing risk. But you want to do more than that. You want to really create one-click library secure by default implementation so that your developers will simply start using. And Black Duck has limitations or equivalent tools. And these developers, they really get excited when they find new cool libraries out there which has high performance or whatever new functionalities. So they download and they use it. So it's really good idea if we establish a good communication channel with them. Hey, every time you use something cool new, let us know.
Yeah,
Once
the problem. We don't have a way to continuously evaluate and know what they're using, because they seem to be finding new things all the time. So that's why I didn't know what was a good way to keep.
And the thing is, there are always less number of people in the security department. So not every POC make it to the product. So let them do their innovative stuff, and always send that survey. Hey, tell me which programming languages you're using. And I'll tell you one thing, I came across some Scala, Ruby, and R applications written in these languages, and there was no static tool that I could use reliably. So I basically, worked with developers, developed secure coding guidelines, and then conducted manual code review, and then created the list of implicit, explicit security control. And every time you use these APIs, how to use them securely. So that's what helped me.
That makes sense. Thanks.
Any other question?
Any other questions?
Are there any good sources for getting those implicit and explicit? Again, I'm trying to think of scale. So, like, if we have like 15 levels, how do we scale and try to make this?
I think for the first time, as a security professional, you need to go through it. There is nothing like available out there. And you need to harden the library depending on your use case. So maybe the Cypher Suite requirement for financial industry is different from government or some other regulations. Just doing blind scanning and taking care of those false positive, true positive, it's not going to generate value. Anybody can do that.
That's why
Yeah. Any other question? I think the first step is if we identify the list of libraries that your developers use quite widely and just go through them, that will be really beneficial.
No, I mean, that totally makes sense. I think we have to start somewhere. That's a good way.
Yeah. And if you're looking for strategy on how to break down a foundational dev framework into different components and libraries, we can talk offline.
Oh, okay.
And how to prioritize libraries, because I was working on a homegrown foundational dev framework. It has 300 components, and we ended up prioritizing 90 of them, 4 at a time.
Okay. I'll sync up with you offline then.
Okay.
That was very helpful.
Any other questions? Can we get a round of applause for our presenter?